Welcome to Chapter 11, Section 2, Multiplying and Dividing Rational Expressions. The rules for multiplying and dividing rational expressions are the same as the rules for multiplying and dividing fractions. What does that mean? That means that you have to look at the factors and those you are able to cancel out or reduce or simplify. So for example, if we have 12 fifths times 15 eighths, we can look at that and realize that 12 is really 4 times 3. We're multiplying that by 15, which is 5 times 3, over 8, which is 2 times 4. Those are factors. Once you consider that, you realize that the 4's can cancel out because you have 1 in the numerator, 1 denominator. This is the same as if we divided the numerator and denominator by 4. The 5's can cancel out because you have 1 in the numerator and 1 in the denominator. Now, these 3's cannot cancel out because they're both in the numerator. And to cancel out or reduce, you have to have 1 in the numerator, 1 in the denominator. So for this problem, your answer would be 3 times 3 over 2, which of course is 9 halves. And just 4 and 1/2. Let's take a look at another example. In the numerator here, I have x, the variable x. In the denominator, I have 14, which factors to 2 times 7. In the other numerator, 21 factors to 3 times 7, and x, of course, is just x. Now again, we can simplify this before we multiply it through. I have a 7 in the numerator and denominator, so I can divide out or simplify by 7. I also have an x in the numerator and an x in the denominator. Now, x is the same variable, so in this problem, it stands for the same amount in the numerator and denominator. So 1 times 3 times 1 has a numerator of 3. 2 times 1 times 1 has a denominator of 2, which is 1 and 1/2. Either answer is acceptable. Here's another example. Again, I'm going to factor out. My numerator is 3 times x times x times x. That's x cubed. My denominator is 2 times 2 times x. 8x squared is 2 times 2 times 2 is 8 times x times x. And 15 is 3 times 5, and then x to the 4th is x multiplied 4 times. And once again, I'm going to cancel. Anything I have in the numerator and denominator can be canceled out. I'm going to cancel out some x's here. This x is gone. This x is gone. The third x is gone. The fourth x is gone. And the fifth x is gone. So as you can see here, what I'm left with in the numerator is just the number 2. And the denominator is the number 5. So not only did I multiply these two fractions, but I also reduced them all at once. When factoring with binomials, you need to think of 3 steps. The first step is to factor out the numerator. The second one is to divide out common factors. And the third one is to then simplify. So how does this work in practice? Well, first we factor. 3 times x times x. And now I'm going to factor the trinomial. So x squared plus 3x plus 2 factors out to be x plus 2 times x plus 1. So now what can be factored out? Well, again, you can only factor out factors. That's why it's called factoring. So sometimes it's easy, like x and x. They cancel out. But sometimes you have to be a little careful because this is a whole factor. This is x plus 2 times 1. You can factor that out, as well as here. We cannot individually factor out the x's and the 2's, but as a whole, we can factor that out. So we are left with 3x times x plus 1, which of course, if we go to the next step, we distribute it, is 3x squared plus 3x times 1. Let's look at this one more time. In the numerator, we have x. We can't factor that. But in the denominator, we have a greatest common factor. That greatest common factor is 3x. So 3x divided out of there leaves x. 3x taken out of here gives a minus 3. And let's factor the next side. Again, in the numerator, we don't have anything factorable there. But in this denominator, we can factor that out. If you use a box method, that is fine. But you're still going to factor it out. Whichever method you choose to factor it, you are now to the point where you can do some canceling. X plus 3 is a factor. X plus 3 is being times by 3x. So that in its entirety can be canceled out with x minus 3 in this numerator. Now we cannot cancel this x out and this x out, because although this is x times 1, this x is not a standalone. It's part of this factor right here. So it's this factor, 2x plus 3, times the factor of x minus 1. So we cannot separate out the individual parts. But we can separate out this x and this x, because they are being multiplied through. So in the numerator, we have 1 times 1, which is 1. In the denominator, we have 3 times 2x plus 3 times x minus 1. And for our purposes here, you do not need to multiply that through. But of course, you're welcome to if you wish. Dividing rational expressions. Dividing by a fraction is the same as multiplying by its reciprocal. This doesn't matter what the fraction looks like. If there's variables in it or not, it's still multiplying by its reciprocal. So the first step that you want to do is always to first rewrite the quotient as a product. So instead of dividing by the fraction, you're going to multiply by the reciprocal. So let's try this. This is a rational expression that is being divided by a polynomial. So first we need to write the reciprocal of the polynomial. Don't make this tough. It's simply 1 over z minus 1. So instead of dividing by z minus 1, we're going to multiply by 1 over z minus 1. As you can see here, I have factored out the polynomial that I have highlighted in green. I'm looking at what I can cancel out. I can cancel out whole terms. And I'm left with z minus 1 over z squared plus 2. Let's do another example. Again, we have 4 times x over x plus 5 times, okay, we're changing this to multiplication, so we're going to use the inverse of the second fraction, x minus 9. Now we don't have a whole lot more here we can cancel out, but x plus 5 and x plus 5 can be canceled out. Reminder, you cannot cancel this x and this x. You do have 1 in the numerator and 1 denominator, but this one's a factor because it's being multiplied by 4. This one is a term because it's x minus 9, so we can't factor those out. So my solution is 4x in the numerator and x minus 9 in the denominator. Once again, another problem. We have x minus 9 over 4x squared. Change this to multiplication, and now we're going to do the reciprocal of x minus 3, which is 1 over x minus 3. I'm going to go ahead and factor. So x squared minus 9 is x minus 3 times x plus 3 over 4 times x multiplied by 1 over x minus 3. As you can see, you can factor out x minus 3 and x minus 3. So you have x plus 3 on the top times 1, and then 4 times x times 1 in the denominator, and that's your solution. Sometimes you're going to see a complex fraction, which means this is just a division bar. So you have the first part of this divided by the second part of this. So let's take a look and see what that looks like. So it means our first part is divided by 2q squared over 2q plus 8. That's our second part. We're going to multiply by the reciprocal, 2q plus 8 over 2q squared. I just took the reciprocal. I'm going to go ahead and factor. So when I factor 2q plus 8, I find there's a greatest common factor of 2, so I'm going to pull that out. And then the denominator, I have 2q times q. Cancel out what I can. Remember, I can't cancel out individuals when there's an addition problem. But if they're a factor, like this is q plus 4 times 1, and this is q plus 4 times 2, I can factor those out. I can also factor out this 2 and this 2. And then I'll go ahead and simplify. In the numerator, I'm left with 1 times 1 times 1. The denominator, I'm left with 1 times q times q. So that's the problem simplified. That's all I have. See you in class tomorrow.